assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
We have here in question number 60 another real-world example to a mass spectrometer, and it's asking us how a mass spectrometer that measures air pollutants can separate carbon monoxide and nitrogen, because they have a very nearly equal mass. So the mass of carbon monoxide is 28.0106 atomic units, and the mass of our nitrogen molecule here is 28.0134 atomic units. So extremely close to each other. The question wants to know, what radius of curvature must this spectrometer have for these two molecules to be separated on the film by 0.5 millimeters. Now, the first thing that we need to know is that these particles are following a semicircular path. And a particle has a displacement of 2r. I'll do this one in red. R from the point of entering that region to where it strikes the film. So if we want the separation on the film to be 0.5 millimeter, then the difference of the radii is going to be 0.25 millimeter. So displacement is 2r. Thus, if this is the displacement between the two of them, the difference in radius is going to be 0.25 millimeters. So, going to our spectrometer knowledge, we write down the force from the magnetic field and set it equal to the centripetal acceleration, because that's what relates us to a radius. And then we can look at this and say, V's are going to cancel. One of them anyway. And the mass is Q B R over V. However, for both of these molecules, the Q is going to be constant. The B is going to be constant. And the V is going to be constant. So we have a ratio M over R that is equal to some constant. Thus, the mass ratio, or mass over R ratio, of carbon monoxide is going to be equal to that of the nitrogen molecule. So, if we say that mass of CO over R, which is what we want to find, the radius, is equal to mass of N2, not squared, N2 over R plus 0.25 millimeters, then we can solve for R pretty simply and get that our R is equal to 2.5 meters. And that is because we know this, we know that, and we can solve for this simple system of equations.